everyone, this is our first of two short lectures for module number 10. Module 10 is a little bit of a shorter module than the rest. I do that for a couple of reasons. First, because I'd like to give you some time to review and get everything squared away for the second exam. We'll have a little bit of review material posted as well. But also because I'd really like to use this as an opportunity to go back over a number of the things that we've learned during our second unit, and to use climate change as a way to go back through some of what we've been talking about and what we've learned about biogeography. Now, climate change is an issue that we've been circulating around for quite a while now, looking at some of the effects of climate change in terms of fire recovery, looking at climate change as one of the possible explanations for why we're seeing some very different fire behavior than we have in past, and also looking at the suggestion that climate change might help to explain a little bit of why the current epidemic of beetle kill is so much more severe than what we've seen in past. But in addition to these frames of disturbance and recovery that we've been looking at most recently, we can also see climate change as an opportunity to look back at some of the core biogeographical concepts that we've been discussing all through this module. So particularly looking at how we can build from ecology, that confluence between abiotic and biotic factors and the relationships between species, and move that into biogeography. So thinking about how habitats and species are not only not only connected, but also distributed in space, and how ultimately they might move through space, particularly as some of those abiotic factors are in transformation. So how can we look at climate change in biogeographical terms? One big part of that is that we're not just looking at climate change as global warming, even though that's a frequently circulated term, and we use that a lot of the time as shorthand. But we're really looking at some of the other disruptions to the climate systems. So alongside a general trend of warming temperatures is the possibility that temperatures in some situations may actually get cooler. Also looking at transformations in the regimes of precipitation, changes to the timing of these climate and weather events as they happen over the course of a year, as well as introducing new patterns of uncertainty and variability to the whole system. And so what I'd like to do during this lecture and the next is to look a little bit more closely at what effects some of these disruptions might have on mountains, how mountains might behave differently than lowland areas, and how we might be able to trace some of these ramifications through ecosystems. So not just saying that mountain climates are likely to change, but that mountain climates will also transform mountain ecosystems in new and perhaps hard to predict ways. Now, way back, towards the beginning of the class, we spent some time with an overview of climate change, and an overview of what sorts of things we can see from the perspective of climate. That might even be a good chance to go back and take a look at your notes from that lecture as a precursor to this. But to sum that up, we can say a couple of important things. First off, we know that global temperatures are warming. This is a trend that we see nearly everywhere on planet Earth. We have a pretty good idea of why that's happening because of the anthropogenic release of greenhouse gases. However, that warming is not equally distributed around the globe, and in fact mountain areas are often warming more quickly than lowland areas. That doesn't mean, however, that we have a good lock on just how severe this transformation will be in future. This graph is actually reflecting what we know both in past based on observations through proxy data, through direct observations, and through predictions using different models both of how climate in fact works and what possibilities of human increase or reduction in greenhouse gas emissions we're likely to confront over the next 100 years. Great international work being done trying to get 200 some odd countries all at the same table and agree to policies, but implementing those policies is a lot more challenging. This sort of modeling, however, is a lot more problematic if we shifted from a global scale, looking at likely global average temperatures, and shift that down to regional patterns of climate and precipitation. So these images are actually coming from a climate report that was commissioned by the government of Aspen, Colorado, trying to say what will happen to Aspen in light of the possible next century's worth of climate change. And you'll notice that these models do several different things. Number one, they're estimating likely changes in temperature and precipitation across two time scales. So here on the left, we're seeing predicted changes in precipitation at top and temperature at bottom for 2030. On the right-hand side, we see the predicted changes by 2100. And you can see some pretty interesting trends across that. On the whole, Aspen is predicted to be somewhat drier, especially during the summers, and somewhat warmer. However, there's also a great deal of uncertainty associated with that. These are described as box and whisker plots, where we see the mean value of different models, as well as uncertainty bars on either side. So whether that's a slight decrease in precipitation or a fairly serious decrease, that's one of the places where we're seeing a lot of uncertainty. Moreover, we can see that in some cases that uncertainty goes the other direction. The month of August in particular, there's the possibility that the monsoonal patterns will increase, leading to more precipitation during that month in the 2030 model, and the possibility of much, much more precipitation in the 2100 model. So it's important to note that there is a lot of uncertainty associated with that data. That doesn't just mean that, oh, it's uncertain, the scientists don't know what they're talking about. In fact, the scientists have modeled this extensively. But that part of honest data modeling is to show a predicted value and the uncertainty associated with it. But even as we look at these uncertainty bars in each of these graphs, we can see a couple of overall trends. And that is increased temperature changes, particularly during the summer months, and decreased precipitation, with some exceptions. So we can really read these as key changes not just for Aspen, but also as predictors of what's likely to happen in many mountains around the world. And we can also look at some of the effects of those direct changes to climate on ecosystems. So, for instance, warmer temperatures don't just mean that it's warmer out at any particular point, but that also really transforms the way snowpack works. It means that mountains don't necessarily operate as effectively as water towers, keeping some of that snow that falls during the winter and letting it melt only gradually, keeping that water available into the summer and into the autumn. Likewise, we're likely to see some pretty massive transformations as glaciers start to melt, as permafrost turns into soil soup. Likewise, already seeing trends of reduced precipitation. But as mountain foliage becomes more stressed, does more evapotranspiration, is literally pumping more water out of the ground to maintain plant growth, we're likely to see a lot less groundwater in mountains as well. And then coupled with that, a likelihood for an increase in extreme weather, as we're starting to see already in some of the hazards and situations we've been talking about. So just as an example of this decreased snowpack, this is an example from Aspen's climate report, looking at just how much snowpack can melt over a course of about a month in time. Now that's very, very dramatic when we see it here on a ski slope, but we need to think about where all of this water is going as well. So that changes how water interacts with groundwater, as well as what water resources are available in mountain streams and flowing downhill. And lastly, we can trace some of this change through mountain ecosystems. And here it's really useful to think back over some of the different components of ecosystems that we've looked at. So we can think about climate change and its effects on physical geography. and some of the different parts of physical geography that we talked about back in Module 1. Some parts of mountains aren't as likely to go anywhere in the immediate future. It's not as though it's not as though the rock composing mountains is under immediate threat from climate change. However, the interaction between those mountains and climatic regimes might change quite a bit, as we've seen with the possibility of less snowfall, less snowpack, less glaciation. And likewise, increased rates of stream erosion will also, over time, make some parts of mountains look a little bit different. More importantly, however, at least for our purposes at this point in the class, are some of the changes that might occur to plant and animal communities. Seeing some of these niches, some of these adaptations, some of these interactions between species and their environments disrupted. And even more important are changes to some of the relationships between species. That's actually going to be the focus of our second lecture. And I'll point out that what I'm saying here is only scratching the surface. As with so many things in this class, this is an introduction. This is trying to look at some key concepts and bring them into communication with one another. But I'm not going to ask you guys to know this material exhaustively. However, I am providing some links to several reports on likely ecological impacts of climate change. One on a global scale presented by the National Academies of Science, and a couple at a more regional scale. One report that was prepared by Rocky Mountain National Park, which I'm going to be asking you to read as part of this module. A second, which is optional but really interesting, released by the city of Aspen. And so this is a subject that can go a lot deeper. I'm trying to both expose you guys to it and lead you to use it as a way to think back over what we've learned about biogeography and review that material.